In this video, I will explain the basic calculation of complex number, i.e. addition, subtraction, multiplication. But division is a bit complicated for right now at this stage. So we will come back to division after we have learned the complex conjugate. In this video, our goal is to solve these two problems. Addition problem and subtraction will follow, and then is the multiplication. We have learned that I squared equals to -1, which is the definition of an imaginary number. And we also learned that imaginary number and real number are distinguishable, they cannot be mixed together. For example, x, you cannot mix x and y. They cannot be mixed together. If you want to use x plus y, you cannot simplify it further. And that's why we express a complex number in a complex plane. And to illustrate further, you cannot add an apple to a banana. So say if you want to buy an apple and banana, it's not equivalent that you buy 2 apples or 2 bananas. And this forms the basis of the addition of complex number. Now we want to add 2 complex numbers together. And suppose you have 1 apple, 2 bananas, and I have, on the other hand, 2 apples and 1 banana. So how many apples do we have in total? 3. What about how many bananas in total? 3i. Very straightforward, but sounds a bit stupid. But multiplication in this case is a bit complicated. We need to make use of the distributive property. So, for example, say the price of each apple is $3, same with the price of each banana. And you want to buy 1 apple plus 2 bananas. And we want to expand this because we want to simplify it further. So what can we say about it? The price times the quantity equals to the price times the sum of price times individual quantity. So that's saying in a simpler term, what's the price for the apple in total? So it's 3 times 1 apple plus what's the price for bananas in total? 3 plus 2 bananas. And it equals to, we can already do this simple calculation, is 3. What about this? Neglect I, just neglect it. 3 times 2 is 6, and we add I again. And this is our result. Now we can already do a real number times a complex number. Now we want to do complex number times a complex number. In this example, let's rewrite it again here. 1 plus 2i, 3 minus I. What do? We want to convert this form into this. And the one way to do this is to think this as a number in total. I don't care what is in the box, in the bracket. I just know there exists a number a. And the whole thing becomes a times 3 minus I. And suppose a is the price, and these are individual quantities. And so the total price is the sum of individual prices minus ai. What we know about a, now we can expand a, is a equals to 1 plus 2i. And we just plug the number a, value of a, into our calculation. and we'll expand this. We can already do the multiplication of a real number times a complex number, 3 plus 6i. And the multiplication of complex number by an imaginary number, it is by analog is to the multiplication of a real number times a complex number, but this time we need to add I into each term. Now be careful when you times minus I times 2i. Minus 2i squared. It's very easy to make mistake at this stage. Now, I squared from definition is minus 1. So, minus 2 times minus 1 is 2 plus 2. So, we add the apples together. 5 and bananas plus 5i. Now this is the basis of calculation of multiplication of complex number. If we want to generalize it further to multiplication of a complex number a plus bi times another complex number c plus di, all we do again is to suppose this complex number is z, and we do the same thing again. We know how to multiply the real number times a complex number, so we just do it. bzi, don't forget the I here, and plug the number value in, c plus di plus bi, no, I put I in front so that I won't forget taking it into calculation, plus AC. Now A, B, C, D are all real, so we represent complex number in terms of real parameter. ADI plus, I'm sure you can do the calculation, plus BDI squared. Now we have 4 terms, and this makes sense because there are 4 terms in total in the original calculation. And one way to quickly do the calculation is you annotate an arrow by connecting the used letter. So for example, I write a calculation AC. When I write a calculation A times C, I write an arrow connecting them together, so that I know that I have already used this term, multiplication of these terms. And until you reach a stage where you cannot draw any more arrows, that means the calculation, the multiplication is complete and you can proceed into the second stage. Now, AC, we can proceed into second. Wait, we'll check it first. AC, ADI, BCI, BDI squared. Now we cannot draw any more arrows, so we proceed, and this is just minus BD, and I will do it quicker. I times AD plus BC. Now the calculation using real number, we get real results. So this is real again, and we get a complex number again from multiplication of complex number. Although we may get real number or imaginary number, but that's the lucky case. And the real part and imaginary part are given by these 2 terms respectively.